So solutions to the ordinary level exam. So the first 7 prime numbers are listed below. What is a prime number? So a prime number is a number with only 2 factors itself and 1. Okay, so that's just one that needs to be learned off. That's the definition of a prime number. Next here, now it starts by saying using the list of numbers above, so we have to work off that list. Write down 3 prime numbers whose sum is 25. So let's see, 13, that's right, isn't it? So if I do 13 and 7, that makes 20, and then 5. Okay? I don't know, there's probably another one, is there? Yeah, 17 and 3 and 5. It will work. 11 and 13, no, that's 24. Anyway, definitely have 2 suggestions, so 13, 7 and 5, and 17, 3 and 5 will work. Write down 2 prime numbers that have a difference of 9. So a difference means when you subtract them, you get 9. So let's see. No. -7, no. Minus 11 and 2. 11 minus 2 is 9. And 3 prime numbers whose product is 110. So product means to multiply. So 3 numbers that when you 3 prime numbers whose product is 110, right? It's too big. I'm just playing around here with the numbers. 13 and 3 is 39. No, 3 times 2 is 26. No. And what about 17? What was that now? 17 times 3 is 51. No, that won't work. And they're going to be too big. Three prime numbers whose product is 110. Definitely finding this harder than I should. Right, 2 times 3 times 5 is too small. 2 times 3 times 7 is too small. 2 times 3 times 11 is too small. 2 times 3 times 13. 2 times 3 times 17. No. So 3 by 5 by 7. Close. 3 by 5 by 11. So that's going to be too big now. Ah, I have it. 2 by 5 by 11. 2 by 5 by 11. I made that harder than it should have been. Anyway, it was just about finding the right 3 numbers that multiply. Okay, so if you multiply 2 by 5 by 11, you do get 110. Okay. The last part of question 1. Sorry, last 2 parts. Write down the next 2 prime numbers after 17. Okay, so 19 is definitely next. And then, not 21, because that divides by 7, so 23 is next. Katie says that all prime numbers are odd. Explain why this statement is not true. Because 2 is a prime number. And 2 is not odd. It's even. Yeah. Okay, so we'll jump into question 2. Okay, so the universal set here is 1, 2, 3, 4, 5. E is the set of even numbers between 1 and 5. So that there is 2, 3, 4. They're the even numbers between 1 and 5. F is the factors of 4. So the factors of 4, 1 divides into 4. 1 by 4 is 4, 2 by 2, and then the 4. So they're the factors. Oh, sorry, doing the answer in the wrong place. List the elements of set E. It's 2 and 4. And list the elements of set F. It's 1, 2, and 4. Okay, so even numbers are numbers that divide by 2. And factors are numbers that divide in evenly. Okay, so we'll do the Venn diagram. Okay, so use this information to fill in the Venn diagram. You always fill in the center. So do we have anything in common in the two sets? We do. Okay, there's a 2 in both sets, so we'll throw that in the center. Once I've taken the 2 out, what's left in E? It's 4. And once I've removed the 2, what's left in F? It's... I'm an idiot. Sorry. Go back. Go back. Go back. What's common? There is more than just... So the reason I came upon that there in my brain when I was doing it was because I was going to repeat a number. You can never repeat a number in a set. Okay, so if you feel like you're going to, that means you've done it wrong. Okay, so I was about to write a 4 here and a 4 here. I was about to repeat a number. You can't repeat a number, so it's a really, really good indicator that you've done something wrong if you're about to repeat a number. Okay, so if I go back to where I asked you, do they have anything in common? They do. They have a 2 and a 4. So what's left, if I remove the 2 and I remove the 4, what's left to put in E? There's nothing. And for F, if I remove the 2 and I remove the 4, what's left? It's 1. Okay, so that's actually quite a good lesson there. Something that you can keep in your brain when you're doing sets is you should never repeat a number. A number should always be inputted into a set only once, into a Venn diagram only once. Okay, so if for any reason you're about to write it twice, then you've done something wrong. You need to take yourself back, just like I did there. Now, obviously, you can't just delete it all, but, go back to where you started. List the elements of F dash, where F dash is the complement. So if you remember your sets, the complement, or F dash, means everything outside F. Okay, so let's have a look. I'll go bigger than that. So here's the set F. So we're looking for everything in the Venn diagram outside of that yellow circle. Okay, so outside the yellow circle is all this all the way around here. Yeah? List the elements that are in that shaded space. There's nothing. Okay, so we would leave that blank because it's a null set, it's empty. Okay, all of the elements in this Venn diagram are in F. So there's absolutely nothing outside F. Okay. These ones are always tricky. we'll have a look. So put a tick in the row of each box to show whether each of the following is true or false. So the one here says E intersection F is equal to F intersection E. So the intersection is the overlap. Okay, so they're basically saying the overlap between E and F and the overlap between F and E. Either way, they're talking about this bit in here. Okay, so if it's the overlap between E and F, they're talking about this bit, and if it's the overlap between F and E, they're talking about this bit. So are they always equal? Yes, they are, because they're the same thing. Now this here, again, hopefully you did your study this week. It's E less F, or another way of saying it is E without F. Okay, and they're saying E without F is a, and that symbol there is a symbol for a null set. Okay, so if we start with the set E, now I know my highlighter is really starting to overlap here. Let's try and remove it maybe. Right, so if we start with the set E, actually I might, sorry, let me go back there a second. Oh, what did I do? Okay, right, so I'm going to start with set E. Okay, and try and shade it in thicker. Shade it in as best I can. Okay, so it started with E and then we want to lose F. Okay, so we want to take the F set and we don't include the F set, so it's gone. Okay, so all we're looking at now, because the F set is gone, is this bit here. So is it a null set? Yes, it is, because it's empty. Let's see if I can take that colour off now, you won't be able to see anything. Right. Okay, so the next one, the little hashtag symbol there is cardinal number. Okay, and that just means that you count the elements. Okay, and this one here is the union, and sorry, the union is everything in this case it's E and F. Okay, so is the number of elements in E and F equal to 3? Okay, so here we're talking about all of E and all of F. Okay, so we're talking about all of this, all of this, and you're asking yourself, in here, are there 3 elements? Yes, there are. 1, 2, and 4. Okay, so that's also true. It's a true statement here. I'm going to go back and tidy up my diagram again. Okay, and the last one. So you can see the difference between that U shape and this U shape. Okay, this U shape, this kind of flattened out U shape, it almost looks like a sideways C, is union. This one is the universal set. Okay, and the universal set is the whole rectangle. Okay, so they're asking us, is the entire rectangle the same as the union? Okay, so what's in the entire rectangle? So inside, here we go again, inside this rectangle, what's in there? 1, 2, and 4. Yeah? And then if we look at inside the union, so here's the union, it's just all the circles. What's inside that union? 1, 2, and 4. So are they equal? Yes, they are. Okay, so all of those statements are true. Okay, question 3. Okay, so we have maths and exam. So M, A, T, H and S are the elements in P. And E, X, A and M are the elements in Q. Write down two different subsets of P. So we're just looking at the first one that have three elements. So I can do M, A and T. And I could do A, T and H. So you can pick any of the letters. You can't repeat, but you can pick any of the letters here, M, A, T, H or S, and pick three of them and put them in a bracket and you'll get that right. Okay, so fill in the diagram. So again, we're going to try and get a little bit of overlap. Hopefully we do it right this time. So M is definitely an overlap. A is an overlap, it's in both. And then I have TH, no, and then that's it. Okay, so I have M and I have A. So once M and A are gone from P, I'm left with T, H and S. And once M and A are gone from Q, I'm left with E and X. So that's what your Venn diagram should look like. And then we have a couple of little questions. Okay, so list the elements in each of the following sets. So we talked about this up there. That symbol there means intersection, and the intersection is the overlap. So list the elements in the overlap, here and here, A and M. We did this up above as well. It's Q less P. Okay, so I'll just use the highlighter for this one. So we start with the set Q and less the set P. So we're going to take this set P and remove it. So those elements are gone. So what's left? Just the E and the X. Okay, next one then is P, and here's your union Q. And P union Q, I explained up above, is everything in P and Q. So literally just start over here. T, H, S, M, A, E, X. Okay, no repetition. We don't repeat in a set. Okay, so you list it from the Venn diagram, that way you'll never repeat, and you just put everything in. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 elements. Okay, and then here's the same one again. Like, I know these are hard to remember and they're hard to learn, but there's only about, like, I think there's about, I'm trying to think of the posters on my wall, is there about 7 or 8 of them? There's not that many of them. So Q dash is everything outside Q. So if I highlight Q, here's Q, we want everything outside that circle. So outside that circle, so here I am in the circle. So outside that circle would be these. T, H, and S. Okay, Abby says that, remember this symbol, cardinal number. So the amount of elements, if I count them, in the intersection is the same as the amount of elements in Q less P. Okay, so we did these. So there's the intersection there for the first bit. So how many elements are in that? 1, 2. So down here, I'm going to write the cardinal number of the intersection is 2, because it was A and M. Now the other side is the cardinal number of Q less P, which we also did. There it is there, and there's 1, 2 in it. So Abby says that they are equal, which means they're the same. Is she correct? Yes, she is. They both have 2 elements. All right, and then the last question. I might just snip it all in while we're here. write down? No, factor of 80 was the last one I got. Okay, so the last two. Okay, so I suppose the first thing here is they give us a nice list of numbers, and very, 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 very important is from the list of numbers above. Okay, so you need to use the numbers above. There is some marks as far as I remember going if you don't, but it's important to read the question. Okay, sum is adding. Oh, that doesn't look like an add. There you go. So sum is addition. So we want two numbers that sum to make 45. Is that right? 12 and 33? And 3 is 4, yeah. So 12 and 33. Okay, there's 12. There's 33. Okay, write down two numbers that have a difference. Difference is minus or subtract. So a difference of 30. Let's make 20. Too big. $33 and 13. No, that's only 20. $76 and 56 is only 20. Oh, 46 and 76. There you go. So if you do 76 minus 46, minus 46, you get 30. Now there might be other possibilities here that I'm not seeing. Okay, next one is write down a number that is a multiple of 7. So multiple is when you multiply, so it's your times tables. So the multiples of 7 would be 7, 14, 21, 28, 35, and so on. Okay, so do we have any of them? 56 is a multiple of 7. If I keep going, 35, that's 5 sevens, 6 sevens are 42, then 49, and then 56. So it's a multiple of 7. Factor of 80, so that's a number we did factor already that divides into 80 evenly. I think I saw actually a few of them. 8 would divide into 80, 20 would divide into 80. And that's it, I think, actually. So either of those. So 8 would divide into 80, and you could also say 20 divides into 80. A prime number, so we talked about prime numbers, they have only 2 factors. 13 is definitely prime. I think that's the only one. 13. What is the largest number you get by multiplying any two of the numbers? So if we're trying to get the largest number by multiplying two numbers, we need to multiply the two biggest numbers. So is it 88 and 76? So if I do 88 multiplied by 76, 6688 is the answer. Alright, I think that's it. Yep. So please go through and make your corrections.